Okay, I think we're going to get started here. Good morning, everyone. Thank you for joining us for our installer training webinar about the QS1, the YC600, and the YC1000. This webinar is really about lowering costs and reducing time on the job site with APsystems microinverters. We plan to cover a lot of good information today that will hopefully help you better understand the APsystems solution offering and, more importantly, be successful at installing APsystems and help you simplify and streamline that whole installation process, which will reduce your install time and save you money. I'm Jason Higginson. I'm the Senior Director of Marketing at APsystems. I've been with APsystems going on 6.5 years now. I've been in the solar industry for 11 years and in power technology for longer than that. On the call with me this morning is Chris Barrett. He's our Senior Director of Training and Field Applications Engineering. He's been with APsystems for about 6 years. And before that, he was with SolarBridge. And he also has extensive experience in semiconductor and power technology. We're both excited to be with you today. I want to let everyone know to please take advantage of part 2 of this training, which is happening tomorrow. So some more information on that. You can easily register for that at the same location you use to register for this webinar, or you can go to our website. You can click on resources and then training webinars, or you can visit our short link, which is usa.apsystems.com/webinars. We encourage you to use the chat box, the Q&A for questions. We'll address any questions at the end. We're going to send you guys a copy of this PowerPoint. This webinar is also being recorded, so we're going to throw it up on YouTube and send you out a link for that. And again, this is part 1, part 2 is tomorrow. Quick agenda. We're going to talk a little bit about APsystems and then go over products. System design, Chris is going to cover system design and installation, and then we're going to do a very brief intro on our ECU, which is our gateway, and the EMA, which is our online portal. And Chris will go into more details on both of those tomorrow. So a little company introduction. APsystems is a global provider of microinverters, power conversion equipment. We were founded in 2010, which makes us 11 years old this year. And we have 4 global business units based out of Seattle for USA, Lyon, France for our Europe, Middle East, and Africa, Jiaxing, China for our Asia Pacific business unit, and then Guadalajara, Mexico for our South America and Central America business unit. We have additional offices in Cupertino, Sydney, Melbourne, Shanghai, and Rotterdam. So we continue to be growing. We're the #2 solar microinverter in the world. We're the #1 multi-module microinverter supplier worldwide. It means our products connect to more than one module. We have over 1 gigawatt installed around the globe, more than 2 million microinverters. We serve customers in over 120 countries. We have over 100,000 systems installed. And then we offer some, we're on AVLs for third-party financing partners like Mosaic, Sungage, Dividend, White Green, and now LoanPal. Chris, you want to take it away from here?
Absolutely, Jason. Thank you so much. Hello, everybody. And again, thank you very much for taking the time out of your busy days. I know it's during the daytime, during the week time, the sun is shining bright. So taking a few minutes to chat with us and learn a little, I really appreciate that. So let's dig in. So APsystems, as Jason just teed up here, basically it's a residential and commercial solution product. And today we're going to talk about basically the 3 different products that we have. Basically, we're talking about the microinverter solutions right here. The ECU-R or ECU-C gateways, the communication devices, and the online portal. I like to call this the 3-legged stool. These is really the simple solar that you need to be able to put together a system on a roof, whether that be residential or commercial, and be able to produce power, easily be able to communicate the information from the roof to the gateway, and the gateway then onto the online portal, back to your computer and or handheld applications. In the commercial solutions, we have a specific product which is actually called the YC1000. This is again a microinverter. But this right here is a true three-phase product. And we'll go into more details on what that actually does and is as we get into it. But the nice thing about this particular product, it is designed for a commercial environment. And one thing I'd like to say here is this is one of those kind of products where it takes a residential installer and turns them into a commercial installer overnight because of the simplicity of using the microinverters in this environment. One thing I also want to point out is the gateways themselves, the online portaling, all identical between residential and commercial installations, both the same. So product-wise, like we just talked about, microinverter designs, there's three different versions we have at this point. The YC600, which again is a dual microinverter. So think of this as actually two inverters in one package. So to serve two different panels. The QS1 here is actually basically four different inverters in a single package. You see this four independent MPPTs or inputs. And then also the 1000, the YC1000 is this commercial product that we talked about, which has a single input because it is a micro string. DC in from the panels, AC output. Again, serving four modules, and two modules. Let's talk about some of the product overviews now. Let's kind of dig in a little bit here. So we talked about this right here, single phase microinverters. This right here is the YC600. Again, we're talking about this being a two inverters in a single package. As you see right here, it can handle two. So we have two inputs, one input here, input one, input two. The nice thing about this product, we call it a single phase inverter, but it can be used in a 240 volt split phase, typical residential, 240 volt delta, 240 volt delta high leg, and also 208Y with a simple firmware change. Basically, it's a signal that's sent to the inverters from a handheld app telling you it will now be in 208 mode. Other important thing is independent MPPT. Customers always ask me, well, what if I have two different size modules? What if I have one module facing east, one module facing west? What if I have one facing south? The independent right here, like I said, this is inverter number one, this is inverter number two. Two inverters, same package, independent of each other, for a maximum of 600 watts per channel. So 300 watts per channel, 600 watts total for the inverter. Coming down, QS1. QS1 is very similar to the 600, but again, as we discussed, it's four inverters in a single package here. So a single unit connects up to four solar modules. And you can see here, there's four independent channels that are coming in here. Independent for a maximum output of 1200 watts. Again, that is 300 watts per channel of the inverter. As far as the cabling, the interconnects that go together here, these are actually used both interchangeably on the 600 and QS1. So it's a one cable for both devices. That's kind of nice. We'll talk about that more as we get deeper into the presentation, but it gives the ability to actually plug and play and have multiple inverters on the same exact trunk line. So as far as the trunk line is concerned, this is what you're seeing here. This is what you'd see in the box. They have two different versions of this, 2 and 4 meters between drops. Each cable has three conductors in it. It has a line 1, line 2, and down the center, integrated grounding, every single cable. For a maximum to be terminated on a 20 amp breaker. So I'll give you just some examples here. For the YC600, you can put up to 7 units, 7 YC600s on a single branch circuit. For the QS1s, you can put up to 3. And that really comes down to just math. It comes down to is how many amps per unit are there available to get to that 16 amps, which is the NEC requirement for a 20 amp breaker. And as we discussed a second ago, mixing and matching is nice because let's say you have, for example, you have a need to have 2 QS1s and a 600 can be easily done on a single line. As far as some of the pieces and parts are concerned, this couldn't get more simple. At the end of every AC bus run, there's going to be an end cap. And inside of this end cap, there's basically 3 different pockets. What you're going to do is at the end of it, you're going to strip back the SO cable, strip the connectors, plug it in, and then tighten it down. This provides a watertight and dust-tight seal at the end of a line. And we also provide a way for you to wire manage this and make sure that doesn't get on the roof. You can actually clip that right to the rails. AC bus connector cap. This right here is, for example, if you had a situation where you needed to skip a drop, this right here is going to be able to connect over top of this drop right here to watertight and dust tight seal again. Disconnect tool. This disconnect tool is used specifically for this here. If you need to make any changes, disconnect anything at any point, this tool here is required, puts it in, boom, boom, boom. Although all you really need is a straight blade screwdriver, can do the job just as well. So it's not a requirement, but it's a nice to have, and NEC does require any cable manufacturer to have a specific disconnect tool. One question we do get asked quite a bit, you have a dual and you have a quad. What happens if I have an odd number of modules on my roof? It's simple. The simple answer is you would just cap off one of the ports on either one of the QS1 or the 600. And by doing that, you'd use this called MC4 caps, MC4 male and female. So you're basically going to cap off the plus and minus, again, watertight, dust tight. The last accessory that's available for you guys is, let's say, for example, you needed to stretch from array number 1 to array number 2. This is the AC side again. You can actually make up your own cables. You can purchase the SO cable, TCER cable from any of your electrical supply houses. Make your cables, make your runs, and have it done via a single connector. Very simple, right there in the field manufactured. Flexibility is the key piece right here. And we brushed on this a little bit, but mixing these products together is a fantastic opportunity here. So let's say we have a system that has 4 inputs here. We have 4 more inputs here and 2 more inputs here. So I can have a total of 10 modules being used on this same connector cable. This connector bus cable. Can have 3 different drops, 2 different style inverters for a total of 10 modules. This is just an example of the flexibility that we provide. The next slide actually kind of shows you a little bit more pictorially. Here it is, again, the QS1. Let's say you need 10, here it is. Add the 600, and boom, there you go. All on that exact same branch line. The next product I want to talk about is the 3-phase microinverter. This is what we call the YC1000. Again, you can actually see down here, there's 4 inputs down here for 4 different solar panels. So this is the input side. It can be used in a 208 or a 480 volt Y configuration. The Y is the key piece of the puzzle here. It does require a neutral for this particular product. But it is, like I said, it's a 5-wire system, line 1, line 2, line 3, neutral, and ground. What I love about this product, again, it's phase monitored and phase balanced. And phase monitoring is really the key thing, as we all know. If you lose a phase, if the utility loses a phase, this inverter will sense that phase gone, and it will kill or shut down the entire inverter. Single MPPT microstring. So again, this is 4 independent inputs, but inside the device is a single MPPT. Again, because this is used in a commercial environment where in most cases, you're going to be sitting on a roof, all modules in the same exact plane, very little or no shading whatsoever. So again, just want to point that out for a maximum output of 1130 AC watts output. This is just an example of different configurations, portrait, landscape, whatever you want, 3 or 4 module designs. Again, because the flexibility, because it is a single input, you can load it up with different size modules. Customers will say, well, okay, well, you've only got 1130 watts AC output. What size modules can I use on this particular device? And again, the question I get, the answer I always give is, you want a right size, and you want to make sure that you stack the deck in your favor. Modules are getting bigger these days. So we could say you could put 4 300 watt modules on here. You could put 3 400 watt modules on here. You want to make sure that you maximize the amount of wattage going into the device, so you maximize the wattage coming out of the device as well. Again, Just want to show you this, like it says 1, 2, 3, 1, 2, 3, 4. You can use 1, 2, 3, 4 channels on that device. It doesn't matter. Obviously, the 3 to 4 would be better, but that gives you the flexibility to maximize your input and maximize your output. As far as the cabling is concerned, this bus cable is slightly different because it is a 3-phase 5-wire conductor. So you can see here it's 5 conductors. If you see here, it is pokey out, so it can only go together in one direction. So there's no chance of putting it together wrong or backwards. It does, again, the same configuration, comes in 2 or 4 meters between drops, coming down to a 15 amp breaker, 3-pole 15 amp breaker in the main box. For a 208 volt system, you can use up to 4 of the the 1000s for a total of 16 modules. For 480 volt Y configurations, 8 units or 32 modules per branch circuit. Accessories, again, very similar to the QS1 and 600. There is an AC end cap. Again, this particular device, watertight, dust tight. Basically, the cable is going to come in here. You're going to flare the end and basically separate those wires. There's 5 different pockets inside this device. This right here is a screw thread. You just tighten this down, becomes watertight, dust tight, right on the end of the line. Again, if you ever needed to miss or skip an AC drop, this is watertight, dust tight cap to accommodate that very quickly and easily. If you, let's say, for example, you do use 3, you put larger modules, put 400, 450 watt modules on the device, and you leave one of them blank, MC4 caps here, again, watertight, dust tight. And again, if you wanted to create extensions, jump from array to array, side to side, back to front, we also do provide AC connectors where you can actually make up your own extension cables from array to array. One question we do get asked is about DC extensions. And this is the cable that we do sell. I mean, you can make your own, but this is a situation where if you have an inverter, you know, obviously all the panels have to get plugged into that inverter. And for example, if you had 4 inverters in a row, let's call them panels 1, 2, 3, and 4, you put the inverter somewhere underneath panel 2 or 3, panels number 1 and panels number 4 would probably need some type of an extension to get those lines back into the inverter. And this is where we sell this DC extension cable. We sell this in a 2-meter length. What I like about it, it is pre-configured, pre-tested, and high-pot tested at our factory. So, and like I said, I mean, many customers can and do make DC extensions. That is fine. But the nice thing about the factory-made one, it's made by a machine, tested by machine, and high-pot tested. So, which basically means that it's seen high voltage testing and it's seen current. You know, continuity is interesting, but having that high-pot testing and having that high voltage and high current go through, verifying that it's good, saves you time and money on the roof. Next part I want to talk about is the gateway. This is the monitoring gateway that gives us the ability and gives you the ability to actually see the information from the site remotely. We have 2 different versions of this product right here. We have what's called the ECU-R. And when it was originally designed, this was originally designed for residential. We also have the ECU-C and originally designed for the commercial. That was the concept. What we're finding actually is in many situations, many people are just using the R. It's a very basic, as it says, basic monitoring gateway. But the nice thing about it, it's compatible with all the products. It speaks the same language, right? So this particular product, and we'll dig deeper in today and a lot deeper tomorrow into the Zigbee technology that we're utilizing here to communicate to the inverters. You can see here that this is much more advanced features. You can see this is basically a hardwired device which has to be put into a NEMA 3R box or better, outside, adjacent to the interconnects. A lot more moving parts here, a lot more functions and features here, but it really comes down to, do you really need those functions and features? So, and that next little look, as we dig deeper into the presentation, you can make a decision for yourself. What do I really need to monitor the status of the system? ECU-C, this is one of the features that comes with it. The addition of having the current transformers. to be able to monitor the aggregate production and consumption of the site. That is really the big feature between the ECU-C and ECU-R. A typical installation diagram is just like we see right here. You're seeing that here's the end cap. This just gives you the whole picture for the 1000. Here's the inverter itself, end cap on the end of the line. This is the bus line that goes all the way back to the distribution box. Again, 2 or 4 meters between drops. If you had to skip a drop, here it is. And cables. All right, so let's dig in a little bit deeper and make sure that we everything's clear to everybody. Again, there's a question and answer box here, so please feel free to put in your questions into the box as we're talking. Some of the questions can be answered while we're actually presenting, and at the end, obviously, we will have a question and answer section as well. So again, let's talk about the 600, QS1, and the 1000 in a little bit more depth. As we know, 2 inverters in one for a maximum output of 600 watts, 300 watts per channel, independent MPPT. Again, so I just want to make sure that's super clear that each one is independent of each other. One of the common questions we do get is what is the recommended module size for this inverter? So this inverter will basically push out 300 AC watts per channel. And one thing that I definitely talk to a lot of customers about is what is the right size for my module? And it really comes down to the STC versus PTC of that module. I think it's important in the industry that we should talk about, and we'll talk about a lot more tomorrow as we get deeper into the specifications of this. But we had a customer that was located in the South that was looking at 400 watt Genco. And he says, I'd love to use your product, but it only uses 300 watts out, and I have a 400 watt panel, STC. And I said, well, what is the PTC of that module? And he wasn't even sure what I was asking him. So we looked on the spec sheet, and the spec sheet said 305, which obviously is what the real world conditions would typically be. Come to find out, that it was actually a perfect marriage for them. So something to think about when you guys are thinking about sizing your system with microinverters, or anything in general, but just interesting to do. One thing that again we'll talk about in depth tomorrow is Zigbee communication. This device right here, you see it right here, is the Zigbee antenna. All of our products, the 600s, QS1s, and 1000 utilize Zigbee technology, so 802.14.5. Very, very similar to Wi-Fi, but just a bit different in the sense that it's a peer-to-peer and peer-to-point network. All of our products have anti-aliasing protection embedded in the systems. This has been there from the start, basically saying that if there's no AC present, the inverters will turn off and not produce any power. NEMA 6, so right here, basically submersible. This device has been tested under 1 meter of water for an hour and still operable. So that includes the casing itself, the AC output, all the DC inputs, and carries a 25-year warranty with a 10-year optional. As far as the pieces of parts are concerned, let's just start up here at the fixture. This is the mounting fixture itself. You can see the mounting fixture here. This is where the bolts would go. We do offer a weeb that would be grounding, so you can actually ground out the rails in this situation. We also do still provide a grounding lug for those jurisdictions that do still require a visible number 6 copper. But remember, inside the cable here, there is a ground integrated into the device. So basically, there's 3 different ways to ground this device. You only need to pick one. And most people in this country, in Canada, will also utilize the integrated ground, which makes the most sense. Serial numbers. Okay, this is where you would actually start to map your site. And then on this particular device, we have 2 stickers here that are removable. This is where you're going to be able to peel them off, create your maps. We also have a integrated sticker here on the face of the device, and on the side of the device, there's also an integrated serial number for future identification. So you have two that are permanent, two that are removable. We just talked about a second ago, the Zigbee antenna. This is molded into the case here. Nothing for you to do as the installer. It's automatically there, automatically will come on and start communicating as soon as we have DC power plugged into one of these ports. LED light. All of our products carry an LED light, so you have a visual indicator of what's going on with the inverter. When the inverter is just first plugged in, when you first plug in the first DC connection, doesn't matter channel 1 or channel 2, you're going to get one flash of red and 3 flashes of green, indicating to you or telling you that you've made a good connection and that that Zigbee chip is firing up. Not production, not power production, but just communication. DC connectors, DC channels 1, channels 2. One thing I do want to point out, all APsystems products all utilize MC4 connectors, DC connectors. We have gone around the gamut, just like every inverter company. We've tried everything. We've come back full circle and only do genuine MC4 connectors. It's become an issue in the industry, so we want to make sure that we're using the de facto standard, which is MC4. And last but not least is the AC connector. The AC connector here, as you see, is the exact same connector as we discussed on the microinverter for the QS1, interchangeable. But again, 3 lines, 1 line, 2 line, and a ground. QS1, very similar to the 600, again, but the big difference is it's 4 solar modules and 4 inverters in the package, if you will. For a maximum of 1200 AC watts output, 300 watts per channel. Independent of each other. Recommended sizes, again, that really comes down to STC versus PTC. Same Zigbee communication, same anti-islanding, IP67 or NEMA 6, however you want to look at that, with a warranty, 10 or 25. Jason, would you like to chat a little bit about the warranty, the differences?
Yeah, so most in North America, most default to the 25-year warranty, and it really depends on your distributor. Some don't even offer the 10-year, but our products are built to meet or exceed that 25-year lifetime. So it's your choice, your customer's choice on what kind of warranty that you want on the products. So it can definitely stand that test of time. I think the question that many customers have are, the technology is moving at such a rapid pace. Am I going to, if I had a 10-year warranty on this the system, would I be wanting to upgrade my system at some point, around that 10 to 25-year mark? And that's really just comes down to customer preference, or whether or not they want the latest and greatest. And so, yeah, that's all I have to say on that one.
Thank you so much. Appreciate it. Thanks for tuning in. As far as the structure, I won't bore you around the thing, but if you're looking at the exact same thing, the removable serial numbers is the key thing. This is where you're going to make your maps. The same MC4 connectors that are on the 600 here are here as well, just 4 of them. The same Zigbee antenna, same LED light, same connectors, same fixture. So the nice thing is, once you understand the 600, the QS1 is the exact same thing, but with 4 inputs instead of 2. As far as the 1000 is concerned, the YC1000 for a 3-phase, again, 4 solar modules inputs, a maximum of 1130 watts AC output, and recommended modules. Again, the 340 to 450 is basically, if you're using, let's say you're using 4 here and using 3 here, 3 modules. This gives you an idea. We want to make sure that you maximize the amount of power that's coming into the device, so you again maximize the amount of power that's going out of the device. If there's any questions, we have a module selection guide on our website, or also feel free to send a message into the tech support team. We were able to help you size those and kind of run through or kind of look at your spec sheets of what you're thinking about pairing with it to make sure we are all on the same page. Zigbee communication. One thing I do want to point out, again, like I said, way in the beginning of the presentation, this right here is key because You're using the same exact gateways, same Zigbee communication, same application, same installation stuff as the 600s and QS1s. So if you are a residential installer and you had any interest in getting into commercial jobs, this would be perfect because again, this gives you, it's a plug and play solution for a commercial application. And using the same communication, you're actually using the same gateways, your installers are using the same tools that they would typically use to install a residential site. Anti-idling protection, that's required. NEMA 6 again, submersible, and we carry that same 25-year warranty. As far as the structure is concerned, it's the exact same as again. So it's wash, rinse, repeat, right? Same serial numbers. The AC cable is a bit different, again, because it is a 5-wire system now. So now you have 3 lines of power, a neutral and a ground. So slightly different, but same concept. The Zigbee antenna, again, molded into the case, nothing for the installer to do, all done. One thing I do want to point out as well, though, LED lighting. The LED lighting sequence for all of our inverters is the same. Once you learn one, you know them all. ECU-R, here again, communication devices. This is the way to transmit the data from the site, from the inverters to the device then to the cloud. Real-time monitoring. This real-time monitoring is basically every 5 minutes. So this device itself will go out every 5 minutes and say, what is your status to the inverters that are in the database? 3-phase or single phase, it doesn't care. It's just talking to inverters. So at the end of the day, super simple device, and you can see why people are choosing the R. It's simple, it's easy to install, easy to communicate. As far as internet connectivity is concerned, 3 different methods. Basically, we've got the Ethernet, which is the best, hardwired, most reliable, built-in Wi-Fi in the device. And stay tuned, you will soon see a cellular offering from APsystems as well. 2 different lights on this thing. So basically one light indicates that you've plugged the device in and it's powered up and ready to go. The second light here is the communication light telling you that you've got a good internet connection and communication to our server. Just that simple. 2 antennas on the back of the device, one for Zigbee, one for Wi-Fi. ECU-C, again, this is just a little bit more advanced functions, but as you see here, does the same job, collection and transmission of inverter data. Again, every 5 minutes I go out and check the status of all the inverters in that roof. Again, 3-phase or single phase, same thing, Wi-Fi, Ethernet, and or cellular connectivity in the future. Same Zigbee communication. The big difference here, as I discussed earlier, is this is a device that will need to be hardwired. As you can see right here, there are all these screw pins right here. Your power inputs, your CT inputs, hardwired device outside adjacent to the power source. And get a feel for some of the devices here. Now, as far as setup is concerned, it couldn't be easier in regards to the application. We have a product that's called the ECU app, easily downloadable from the Apple Store or the Google Play Store. This is an app that will guide you through the selection and scanning of the serial numbers that you are going to be installing that day. The nice thing about this product, it's super simple, just like every other app. This app gives you so much information. I always say that this app turns the ECU or gateway from a toy into a tool. This is a tool that every one of your installers can have on the site. Everyone can verify their work, and before they leave the job site for the day, they'll be able to verify that everything has been installed properly, that DC connections have been made, AC connections have been made, power production has been proven. It's kind of the report card for the installer for the day. So as business owners, there's nothing better than actually knowing that the job was installed, everything is working properly, and then you don't have to roll a truck tomorrow to fix a problem you could have fixed the day of installation. And like I said, come tomorrow. Tomorrow we're going to dig in a lot deeper in this particular application. And we put a lot of time and effort into designing this tool that I think that you really would like to know more about. So. Okay. Jason, you want to jump in?
Yeah, thanks, Chris. Appreciate that. So now that Chris has covered a lot of the technical details, we're going to basically run through why you would want to use APsystems in your projects. So first of all, there's a simple system design, the microinverters. They can easily adapt to any module placement. You got a lower microinverter cost because it makes sense. You've got several inverters in one. And that also reduces your, can we back up one slide?
Cool.
I think I think we may have skipped ahead one. There we go. And because they're serving multiple modules, you've got reduced installation cost. That mix and match is really convenient between the QS1 and the YC600. As Chris mentioned, they use the same accessories, so same trunk table, same connectors. You're stocking less units and less equipment inside your truck. The reduced stocking costs. So, for example, if you're working with string inverters, you don't have to stock multiple capacities of an inverter model. And you got the same ECU that works for all three of those microinverters. Flexible sizing. The system can easily grow. You don't have to replace the inverter or oversize the inverter right at the start. You simply add more microinverters using the same ECU. Each ECU can handle a ridiculous number of microinverters. How many is it? How many panels can connect to one ECU? It's like 400?
400, correct.
And you're not going to use that on a residential system. So with the residential, you can just keep expanding. If they want to put more units on the garage, you can do that same ECU. So again, the simple system design that I mentioned, lower microinverter costs because you have multiple units in one box. That faster communication, it really allows for that communication to come back quickly. And there's every day that there's more data that our customers want from the product. And so we made sure that that's set up in advance. It also allows us to do firmware upgrades in the field, which is really handy. The design of that, I mentioned the field upgradability, that FPGA architecture that we utilize allows us to do that field upgrading. It's inherently rapid shutdown compliant just by design because it stays under that 80-volt threshold, which is really convenient not to have to worry about rapid shutdown, particularly in commercial applications. We have a superior technology. We have high reliability. We are California Rule 21 on the YC600 and the QS1. We have a local support team. We don't send any calls overseas. Our systems are built to last. We have a durable NEMA 6 metal enclosure. It's not plastic. We had DNVGL do all of their system testing on our dual module and our three-phase products, and they passed with flying colors. We have 20,000 hours accelerated life testing that we do on each of our product models with a less than 0.5% global failure rate. Also, our financial foundation is strong. We've got a very strong financial backing. We have cash reserves. We even have our warranty reserve that we have. Basically, anytime somebody gets a 25-year warranty, the difference in cost between that 10-year and that 25-year, when we get that money, we put it into our warranty reserve, and we haven't had to touch that in the entire time that we've been doing business. It's more for like, any kind of catastrophic or systemic problems, and we've never had to use it, but we still have it. So even if there is some sort of disastrous issue, your system and the warranties there are completely covered. We've been profitable every year for now the past 8 years. So there's some confidence in the safety net that APsystems has built in place.
Great. Thank you, Jason. Appreciate it. All right. So let's dig in a little deeper. So on just some of the design and installation criteria here. So as we kind of discussed, YC600 and QS1 can be used in a 240 residential split phase. But what's really, really nice about this, 240 Delta, 240 Delta Highlight, and 208Y. So you have a single SKU, so either 600 or QS1, that can work in 4 different grid types. Real slick. And like I said, the 240 split, 240 Delta, 240 Delta Highlight are native. There's nothing to do. You just plug it in and plug and play. The 208, again, just requires an AC configuration, all via the application right there. So within a 5-minute window, you're going to turn it from a 240 volt inverter into a 208Y inverter. Very simple. If you are looking for that residential, that commercial solution, the YC1000, plug and play, a 3-phase 208 or 480Y. Again, this is the 5-wire system, 3 lines, neutral and ground, phase monitored, phase balanced. Plug and play, couldn't get any better for your commercial environment. Module types doesn't really matter to us. 60 or 72 cells is all I really care about. And I should actually double those numbers. Just do 120 and 144. Split cell modules, no problem whatsoever. Mono or crystalline. We don't do 96 yet, but stay tuned. And we, like I said, we talked about earlier, we have a module compatibility chart on our website listed, so we can actually plug in the information that you have from your module to find out if it's compatible with any one of of our inverters. Layouts, again, fairly simple here. If you have, let's say, a 600, so as we know, it's a 2 input right here. So this is a 600 portrait. So here, you're going to look at this and say, okay, I'm going to have the inverter somewhere between module 1 or module 2. The 2 inverters are going to come together, and the panel's going to come together, plug into the inverter, and done. 2 meters or 4 meters between drops. This is an example of a 2-meter bus cable right here. But again, one inverter will serve 2 different modules. Let's do the same thing, but let's do it in landscape with 2 different rows. You can actually do it here, again, using 2 meters between drops, because you're actually going to do the 2 modules this way. Again, very easily. So design flexibility couldn't be some more simple. So we're doing landscape, but in a 2-row configuration. This just gives you an idea of flexibility of what you can and can't do. Here's landscape 1 row, okay? And this is exactly where you'd see you'd be able to put the modules themselves head to head. You'll be able to actually connect one inverter to 2 different modules very easily and be all on that same exact bus line right there. What we're demonstrating here is actually the 4-meter cable, because now in landscape mode, you're going to have a little more distance between each of the inverters. So that 4-meter cable is going to make a huge difference as far as your flexibility is concerned. Let's try to take it to the next level here. So this is the YC1000 or QS1, the 4-input inverters, portrait 2 rows. And you'll all hear me in these training sessions. You always hear me about the 2x2 configuration, 2x2. Here it is, 2x2. You get 2 here, 2 here. Again, inverter goes right down to the middle here. Junction boxes are all facing each other. So they're shorter leads, and in most cases, we'll be able to plug in directly. If you do end up in a situation where you have the split phase modules, where you have the leads in the center tap of the devices, that's when you will need or may require the DC extensions to make these connections. Portrait single row. Again, DC extensions may be needed. Let's say, like we did for the example, module 1, 2, 3, and 4. So for 2 and 3, they plug in directly, natively. For the 1 and 4, you may just need those DC extensions to reach into the device. Same thing here in the landscape mode. If everything is head to head, if you're on a standard module, plugs in natively, no problem at all, without any extensions. But again, if you do have any kind of center tap devices, you may require those DC extensions. Let's dig into the installation. System installation, super simple again. As far as we'll start at the back and work our way forward, right? At the end cap of the line, there's always going to be an end cap. You're going to come into the first drop, where you're going to collect your microinverters all the way down your bus line to a junction box somewhere on that roof. Every connector will be utilized in this particular case. In this particular case, we're showing 10 modules, YC600, 2 QS1s. Junction box, either you're going to make up your own connectors to go to a different junction box, or you're going to go through AC cable down to a distribution box here. Let's see here, the ECU-C or ECU-R, really up to you. Like I said, the ECU-C would be hardwired into the distribution box, whereas the ECU-R does not need to be hardwired. It just gets plugged into a normal socket in your residential or commercial environment. These two devices, ECU-C or ECU-R, connect to a router. That router obviously goes to the internet, and that's where you're able to see all this information remotely. And this just gives you another more schematic view of this particular setup. Again, inverters, this is a single string coming down to a junction box, another string coming into the junction, and a third string coming into the junction. All communication via Zigbee to the inverters. Distribution box, very simple. Again, connectivity, we talked about 3G, 4G, we talked about internet via the Ethernet or Wi-Fi. Whatever you choose, we have it for you. Jason, you want to talk about some of these?
Yeah, so this system is actually on Bainbridge Island, and it utilizes our YC600 and QS1. We've actually done a couple of communities on Bainbridge Island that are similar to this one. And the idea with these homes is they want to be a net zero system for the entire home. So they want to be energy neutral. So they're bringing in as much renewable energy as the home is using. So this one is one of our more recent ones. I believe it's called The Walk on Bainbridge Island. You can check that out online. And yeah, it's pretty cool. They have the systems on the rooftop, and they also have these awnings that also act as window shades. So it's a pretty slick system.
Yeah, and one thing I wanted to point out is that the customer that installed this did a mixture of 600s and QS1s on this particular site. Good example of mixing and matching. Thank you, Jason.
Mm-hmm.
This is a bit of an eye chart, but we're going to go through it and kind of pictorially. But one of the things I want to definitely make sure that it's clear is one of the first things we want to do is, as a new installer with APsystems, get your EMA installer account set up and send a request in to APsystems.com. So if you go to APsystems.com and you go to the support page, you're going to find a place where you can actually type in your company information, your name, your email address, phone numbers. All this information is critical for us to set up an account for you to be able to get a system installed, having that information pushed back to the cloud so you'll be able to see, monitor your site remotely. The second big part is scanning those serial numbers. And like I said, this is going to go into detail tomorrow. We're going to just touch on it today, but tomorrow is going to be the more detailed version of this and how that's actually done and the importance of that. The nice thing about it, and like I said, we'll dig in deeper tomorrow, is you can actually pre-configure your system before you even install it. All that work can be done up ahead of time. You don't need to send IT professionals out to the field any longer. That can all be done back at your factory before you even leave, before you even pack the truck. So that's kind of nice. So let's dig in. Let's dig into some of the details here. I'm not going to tell you guys how to install things, but again, it's super simple. Where you're going to mark your inverters. Measure it out, figure out where they're going to go, mark it with a pen, and move on. Wire management. You can actually do cable ties, cable clips, whatever you choose, whatever your jurisdiction requires. We don't have a preference on one or the other. I'm a bigger fan of the larger plastic clips or metal clips, just because this is going to be sitting on a roof for 25 years or more. I want to make sure that the longevity is there and you have good wire management and wires not sitting on the roof, a year later. Attaching the inverters. One question that we do get asked quite a bit is, what orientation must the inverters be in? And there actually is no orientation requirements. What we do ask is that it's actually underneath a solar module and that it has at least 1 inch around the entire device. And there's two reasons for that. Number one is, especially in the northern climates, we want to make sure that when there's a heavy snow load on the devices, that the module itself is not coming in contact with the inverter. The deflection of the module. Second is we want to make sure there's good proper cooling as well. It's a warm environment sitting on these roofs. So we want to make sure that there's good airflow around the device. So we do have that cooling, convective cooling going around. So as far as orientation is concerned, like I want to just point out here, on a ground mount, this customer chose to do it vertically. That is totally fine. No pressure, no issue whatsoever. You know, and this is your typical case, roof mount on a roof, on a rail. Again, very simple to mount, but orientation does not matter. You can do it front, back, whatever's convenient for you. As far as the directions, it doesn't have to be M8, but this is what we recommend, again, in the rails, but every rail is different, so it's hard to recommend a certain exact number, exact bolt, but typically 2 bolts per inverter is enough to hold that there and make sure, like I said, one thing we do say again here is that 1 inch of air gap for heat dissipation and make sure that snow load does not come in contact with the device. Same thing with the QS1 and 600. I mean, it's a QS1 and 1000s. Again, all we're trying to demonstrate here is it's just a 2-bolt configuration to ensure that you have good adhesion to that roof. Make sure that you've crushed that weave right there. You've got good kind of conductivity. Just that simple. And again, that 1 inch of air gap around the device. Basically, think of it as a 1 inch envelope of air around the device for good cooling. As far as connecting the microinverters to the AC bus cables, super simple again. I mentioned earlier it was a pokey-yoked connection. So basically it means they can only go together in one orientation. It cannot put it together wrong. There's 2 little tabs on either side of the device. So you'll hear a double click, like a click, click, when you're putting this together. So you have you can feel it, but you also have an audible click to know that you've made that AC connection proper on the roof. In regards to the end cap, this is actually a really good picture of that end cap. So the screw cover is off it right now. So what we're saying is basically you're going to strip back the jacket on the SO cable. In there, you're going to basically flare these lines here, and you're going to fill this pocket. So you got pocket number 1, pocket number 2, and pocket number 3. Basically, we're trying to separate these lines so there is no shorts happen in the system at all. Then you're going to take this nut, you're going to put this nut right back onto the body, screw it down, and in that's the seal that's right here is going to create that watertight and dust-tight connection. As far as the installation map is concerned, we talked about those removable stickers. All you're going to be able to do from our website, you're going to be able to, you can download this, you can do it on a piece of cardboard, whatever you'd like, whatever your preferences are, it doesn't matter. But at the end of the day, you're going to be able to pull that off and then map wherever you've installed those inverters. So when you get back to the office, you're able to actually drag and drop those inverters, channel 1 and channel 2, wherever they are physically on the roof to represent what has actually been installed in the field. AC junction boxes, again, I don't like to tell you how to wire everything up, but this is typically, you'll see these connectors coming in from a branch circuit. They'll come in, you can actually extend what you want, but again, watertight seals and glands here into a box using our connectors or making your own. Either way is fine. Or junction boxes again. A lot of times you'll do this AC cables, a lot of times Romex, sometimes people do it in just regular conduit back down to the distribution. So from the roof back to the distribution box, again, that depends on your jurisdiction as well. Microinverter connections, I talked about this before. When you make that first connection, when you make that DC connection here, you're gonna get a flashing red and 3 flashing greens, telling you that the microinverter has started up communication, not power production. And There's also all kinds of information that can be gathered from this LED. And again, this is standard on all of our products, even our legacy products as well. That LED has been on this product since the beginning of time. The LED status lights haven't changed. The configuration is exactly the same. So like I said, once you know one, you know them all. Okay. Oh, we just talked about that. Sorry about that. A second slide in here. ECUs. ECU placement is a big deal. Like I said, with the ECU-R, that can be placed inside, could be placed on someone's desk, in their house, adjacent to the router. Super easy. With the ECU-C, that again, as we talked about, is a direct wire device, so it have to be outside or adjacent to the distribution panel. The ECU app, again, which we'll talk about a lot more tomorrow. This right here is your tool. This is a very good tool. It can be downloaded from the Google Play Store or the Apple Store. This is where you do your basic setup times, scanning the microinverters. We basically have a system scanner in there where you're able to scan the serial numbers. You don't have to type anything in. Very, very simple. Arranging the layout app in the EMA later. So this is what I was just talking about. You can actually scan all the serial numbers, get everything set up, installed, and verify that it's working properly. When you get back to the office, that's where you can use a large computer, a large screen, and drag and drop the devices wherever you installed them. And to verify communication, like I said, the power of this tool, and you'll see it tomorrow, is to be able to know on site. The installers now have information in the palm of their hands. Everyone on your team and on that job site can dial in and look at the device and verify that, yes, all the inverters have been installed, all the inverters are communicating, all the inverters, the DC connections are good, AC connections are good, and power production the day of installation. Like I said, last thing I want you guys doing is rolling trucks tomorrow for a problem that could have been noticed and solved today. So tomorrow, we'll learn a lot more about that. And this just gives you another idea here as far as the system. And again, a lot more tomorrow. But I do want to point out that it's monitoring and analysis. It gives you a lot of information as far as power production. Around the clock monitoring, obviously this is going to be available to you 24 hours a day, wherever you are in the world. Detects and alerts performance issues. This is a big one right here. This is there. So what we have on the system, we've designed it in such a way that installers will get notified if there's an issue on the site. The site itself will have to have the issue kind of happen for 3 days in a row. So it'd have to persist for 3 days. After 3 days, we will send you an email. We'll say, hey, Mrs. Smith's site has an issue with inverter number 123, and you might want to check these 3 things. So it's a little bit of information, gives you enough information, but we will not notify Mrs. Smith. We'll only notify you so that you can proactively look and see what's going on with the system, and then contact Mrs. Smith and tell her, hey, listen, it looks like we got a problem with your system. We'll be out there, in 2 weeks from now. So it's more of a proactive approach. One thing, and again, we'll talk about more tomorrow, is that we have this online and the application, handheld application. So both, in your phone applications for monitoring and also on the computer. Final steps are here. We'll talk more about this tomorrow. This is where you'd actually go in and create the site for Mrs. Smith. You'd be able to connect to her account, finalize configuration, provide them with their login information. And we'll demonstrate this tomorrow, takes them to a different place than it takes an installer to. So there's basically 2 different accounts. Your installer account will take you to your installer page and your fleet view, and their, or homeowners or site owners view, will bring them to specifically their site. And again, big walkthrough tomorrow. Jason?
Thanks, Chris. Appreciate that. So I wanted to point out some additional APsystems resources. So this training that Chris has been doing, it's a great resource, but it is timely. Like it's at a specific time, and we wanted to make sure that everyone had resources that they could go to when they're not able to jump on a webinar or review that. So we have, first and foremost, our support page on our website. So it gives you kind of the 1, 2, 3 steps to give new installers some information on how they can get up and running. There's also a form there to quickly contact our support team. So when you send that when you submit on that form, it goes into a mailbox that everybody on our support team can access. So we have some people that tend to send a message to one specific person on our support team, and the only challenge with that is if that person is not working that day on vacation or sick, or if they have a heavier workload than some of our other techs. Having this using this support page and having it go to a mailbox that everybody can respond to, it really guarantees that you have somebody getting back to you in a timely manner. We have information on our training page. We have more detailed training like what Chris has covered, plus some user-friendly videos, how to get the ECU up and running, how to use the ECU app, and some other kind of 101 information on some of our microinverters. Highly encourage you to check out some of those videos. They're not very long. And especially if you add new team members onto your crew, you send them to that training page, have them watch the videos that are on there, and they can quickly get up to speed on how to make that difference with APsystems. As Chris mentioned, we have the registration page. And you'll see all of that in the menu. When you look at our resources page, you'll see support, training, registration, our documentation library. All of those links will be readily there. So it'll be intuitive. So you just click on the registration page to add yourselves as an APsystems installer, and we'll set up that account in our portal for you. The product documentation library, it not only does it have our specs, but it has our manuals, which have much more detailed information, as you can expect, than we actually cover in these webinars and in our videos. So yeah, highly detailed. Encourage you to review those when you do an installation, because there may be some specific information that you need. In those, we also have all of our certifications that are on there. So if you have an inspector that asks for a particular certification, just go to our website and you can find them all there. We also have quite a few demonstration videos and explanation videos on our APsystems YouTube website. So just go to youtube.com/APsystemsSolar or search APsystems on YouTube and access our corporate account page. And all of those videos are there for you. We have two different types of videos for each of our products. We have one video that combines all of the individual steps into one 25-minute video. Or if you're looking for one specific thing, you can go to that part. So as you can see in the description here with some of the video thumbnails, you can see ECU-R setup video 1, introduction, setup video 2, features and overview, setup video 3, placement, etc. So each of those videos can give you a specific instruction on what to do in that moment, or you can have your team just watch the entire video to get the whole gamut of instruction. So some training that's going to be continued tomorrow, where we're going to cover the ECU installation, setup of the ECU using the ECU app, and how to do the final steps in the EMA to get everything up and running. Again, you can go to our website. Actually, this is wrong. We don't have it linked on the homepage anymore, but it is under resources if you go to training webinars. So that's our presentation for today. Go ahead and use the Q&A box to send us any questions, and we'll get started on reviewing those and answering those at this time.
Okay, Jason, I see one just coming in here. A good question, actually. Can I add a YC600 microinverter to my old ECU and mix it up with other YC500s? The answer is no. The reason is, so the answer, well, actually the answer is yes and no. So you electrically can put YC600s and YC500s on the same house, on the same lines. They will produce power all day long. What you will require is a new ECU to communicate to the YC600s. The reason being is the YC500s communicated via what's called PLC, or power line communication. So again, to answer the question, and honestly, you can put a 600 and a 500 on the exact same site electrically. It will produce power. As many people have done it, you will need two different ECUs to talk to two different kinds of inverters. Both inverters will produce the power, but again, communication protocol has changed. By adding the Zigbee communication, we've departed from the power line communication. And the reason we did that, just so it's super clear, is NEC requires arc fault breakers in the 2014, they required arc fault breakers in all bedrooms. And where do people put their offices? They put it in a bedroom that is now protected by an arc fault breaker. So there's two problems with that. Number one is trying to pass a PLC signal through an arc fault breaker is impossible. And doing the process of attempting to even do it, you get false trips on those arc fault breakers. And I'm sure many of you on the call have experienced this type of issue. So in 2017, NEC made it even worse by actually saying, okay, now it's not just bedrooms, it's all living spaces. So now the ECU that was located somewhere in a living room is now protected by an arc fault breaker. So we at APsystems made the conscious decision to change from PLC, power line communication, to Zigbee communication to avoid this arc fault breaker issue. And in doing so, we've actually made it so much better for you and for us. When we introduced the YC600 with Zigbee communication, and customers like yourselves installing the ECU or a gateway at the customer's router with a hard line connection, we literally reduced our calls, our tech support calls, by 50%. Just imagine you not rolling a truck to go fix a Wi-Fi connection. You're not trying to find a good, clean PLC communication somewhere in the house. Those are nuisance calls for you. I want you guys to get calls and say, I want more solar, not, why is my system not working? Because I changed internet providers. So good question. Thank you. Another one here. What is the maximum input for each MPPT on the YC1000? Good question. So just a reminder. So the YC1000 is a single MPPT. So it really depends on what you want to put into it. What I think we need to do is look at the maximum AC output, which is 1130 AC watts output. And like I suggested, stack the deck in your favor by making sure that the modules that you choose to put on there exceed that AC output. Not by a ton. I mean, you don't want clipping. This is a word in this industry that's considered negative, and but I'm a big fan of right sizing the system in such a way that you are actually producing as much power as possible. Just remember, the inverters themselves, this inverter will put out 1130 watts AC watts for its lifetime. The modules themselves, as we discussed, there's STC of the module, which is the perfect world conditions, which you'll never see. The PTC, or in some countries it's the NOCT, is, I guess, no more the practical, what they expect you to get out of that module. That will only degrade over time. And most module manufacturers will print that on their spec sheets. In 10-year period of time, they guarantee that 80% of the value. So we know that the modules are going to degrade over time. So right sizing the modules from the start, pushing that inverter as hard as you can for its lifetime is really the key component here. So again, if you get a chance, good question, but go onto our website, plug in what you have, what you're thinking about using for module sizes, and let the thing do the math for you. But good question. Another good question, Zigbee limitations. Just came in. Remind me of the distance limitations of the Zigbee communication. So Zigbee, let's just back up a little bit. So Zigbee itself is very, very similar to Wi-Fi in the sense that it communicates at the same exact frequency, 2.4 gigahertz. It actually uses the concept of the router and the device, or the point and the peer. What Zigbee does offer is this additional piece, this peer-to-peer communication. Let's say, for example, I'm on the phone here, the webinar here, and Jason's on the call, and I know he's on the call. I can see him here, but for whatever reason, he can't hear me. I will actually go out and I will say, hey, Hunter, can you talk to Jason and ask him this question? Hunter will ask the question to Jason. Jason will then respond to Hunter. Hunter then reply back to me. This is that peer-to-peer communication that Wi-Fi doesn't have. Wi-Fi in our homes and businesses is that peer-to-point communication. So it's your router to your computer, your router to your phone, your router to your Xbox. It's all this back and forth to the router. With Zigbee, we've added this extra element of this peer-to-peer communication. So every single inverter on that roof is considered what's called a node. And each node is going to try to find the path of least resistance. I mean, the ECU or the gateway wants to talk to everybody individually. It just makes sense. But if that path is obstructed somehow, the path of least resistance it's easier to go through Hunter than it is to go to Jason. I'm going to go to Hunter every single time. So that's just a little bit more information about the Zigbee communication. The actual distance is the theoretical max is what we call 100 meters. So just like Wi-Fi in your home, how far away can you walk away from your Wi-Fi before you start losing signal? And like I said, I don't need 5 bars. I just need 1 bar. So I would say the theoretical max is 100 meters, 330 feet, but workable distance is probably, you take any kind of obstruction in there, right? So if it's just metal, wood frame houses, that kind of stuff, you're not going to see a major issue. If you got, if you're down in the basement and the array's 3 feet above it and you've got a metal roof and concrete block, you might want to move that a little bit closer. So it really depends on distance and obstructions. My general rule of thumb is somewhere in the 200-foot range for good communication. Let's say, for example, I live in Texas and we do a lot of pole barns here. We do outcrops, we barn, whatever we want, ground arrays, ground mounts, whatever you want to call it. In that particular case, when the distance is greater than 200 or 300 feet from the residence or from the internet source, then I will add something in there. I will put the ECU or gateway at the array in a weatherproof box, NEMA 3R or better, and then backhaul that information back to the router using what I call the AirWire. It's a product made by Ubiquiti. We don't sell it, but it's something that I've highly recommended for years and years. These devices are basically Ethernet over the air, and that can go upwards of 5 miles or more, depending on which one you choose. But so as far as connectivity, reliability, obviously the closer to the devices, the ECU closer to the inverters is good. But again, I want to focus on, can you make a phone call with 1 bar? Yes. Can you talk to an ECU and inverter with 1 bar? Yes. So theoretical max 300 feet, ideal operation 200 feet, but just gauge it. It's how far away can you walk from your router, before you lose signal? How far away can you walk away from the ECU before you lose signal? Good question. Got a question coming in. How do you propose to wire 4 modules in a flush mount rail system on a slope roofed application? That's a good question as well. If it's only 4 modules, and flush mount is tough because there's not a lot of space. That's the problem. It really depends on the distance between, the roofing material and the mount themselves. If it is truly a flush mount, and then there's not enough room to have that 1-inch air gap that we talked about around the inverter, it may not be the best application for this particular product, let's be honest. If you have enough room and you can drop that inverter down so it's 1 inch away from the roofing material and 1 inch away from the face of back sheet of the module, it would be perfect. If you could have your junction box right there underneath there. We do also sell a single drop trunk cable, so you don't have to buy the multi-drop trunk cables. Most customers do, but if you have a situation where you're just putting in 4 modules and that is it for this particular device, recipe for success, because then if you have enough room, like I said, that 1-inch air gap is critical though, because if you're in northern climates, we don't want the snow load to come in contact with the inverter, and obviously just the air gap for ventilation is critical. Hope that answers the question. So, but if you have any more questions about that, I'd love to have a conversation with you. Give a call to the tech support line. We can connect. Another question came in. Is there a timeline on a larger AC output product? Yeah, we're always developing new products. Things are always happening. Those kinds of things are typically introduced at times of trade shows, things like that. And I know that we got a big one coming up here, SBI, and hopefully if things get a little better, we actually might even have an in-person trade show again this year. So I guess my best answer for you is stay tuned. But APsystems is committed to keeping up with the modules. The modules are getting bigger and bigger every single day. We want to make sure that we are compatible with every module going forward. But one thing I do want to say is I think that, like the example that I did give earlier, customers are concerned and saying, well, you got a 300 watt module, but a 300 watt inverter, but I've got a 400 watt module. Do the research, ask the companies. A lot of times the companies won't publish the PTC. They won't publish the NOCT of the module. And that is more the real world, what they expect that module to get. Think of the STC as the window sticker on a brand new car that says you're going to get 35 miles a gallon on that new car. And you buy the car and you drive it around for a month and you're saying, well, crap, I'm only getting 30 miles a gallon. Where's that 35 miles a gallon come from? And of course, right, according to their measurements, that's the best case scenario. That's the test conditions. That is a perfect car on a perfect track with perfect tires, perfect temperatures, no weight in the vehicle, all yada, 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 yada. Same thing with the modules. Modules themselves are manufactured, tested in an environment. They have perfect light, 1,000 watts per meter squared, flashed onto them, perfect temperatures, perfect wind, everything. So I would say that let's take a look at those things right there. Look at the PTC, ask the questions of the module manufacturers. What is your PTC? And one better, I always recommend, and I always say, don't believe me, believe the state of California. That may be kind of a funny statement, but they have a really good database of all of the modules that are allowed to be used in California. So basically they go through and they test all the modules that are on this list. So the manufacturer says, okay, here's the module. It's a 400 watt module, like that Genco example that I made. So I think it was a 405 actually. I think it was 405. And they went through the testing and the state of California says, well, it's a 405 STC, but it's actually a 305 PTC. So like I said, do your research, ask the questions to your module manufacturers or your distributors, find out what the real world expectations are, and then make your inverter decisions based on that. I hope that helps. I know we're cutting over a little bit of time here. Is there any additional questions?
I'm not seeing any on my end, Chris. And somebody asked if they can get the recording, and yeah, all the registered attendees, we're going to send out a link where they can view this online. So at this time, I'd just like to say thank you for your time and thank you for your involvement and your questions. We appreciate that. And if you have any questions, please visit our website. You can also email us either at our info.usa, sales.usa email addresses, or you can contact our support team if you have any installation questions. All right, thank you everyone. We appreciate your time today, and have a great day.
Thank you everyone. Have a great day. Thanks for your time.